All right, so we're going to be doing section 6.3, separation of variables. Now, I told you guys that we're going to be using the problems from section 6.1 worksheet, okay? So I'm going to ask you guys to get to the first page. So we're basically going to do, so you guys can maybe mark these off, numbers 1 through 6 on the worksheet. Okay, well, we're not going to do them, but you are. I'm going to do some of them, okay? So 1 through 6 on the worksheet, and then you're also going to do 15 through 18. Okay, so page 1 and page 3, 15 through 18. You don't have to match up any of the slope fields. You're going to actually find the general solution for me, okay? But let me show you how this goes. Like there is no like instructional routine, like here's step 1, here's step 2, because every problem can be a little different. But I do want you guys to kind of understand how to get to what we need to do. Okay, so let me show you some examples of how we separate variables, and I'm going to actually mark off point values that will most likely be given for every step that we do. So this is number 2 from your homework. Okay, so actually I may have done number 2 for you guys on the previous notes. Yeah, I did. So let's not do number 2 here. If you look at the notes that I just sent out this morning, number 2 should already be done for you guys on the side. Okay. So let's try doing, I don't know, maybe I won't make you do all of them, but let's try doing number 6. Number 6. I might have to pick and choose what I have you guys do. Maybe not all of them, because some of these won't work out as nice. So dy dx is equal to negative y over x. Okay, so this is the way separation of variables works. What they're going to want you to do is they're going to want you to try to figure out what equation gave us this derivative. Okay, what's the equation that gave us this derivative? Now, because there's a y and an x in the derivative, that means that it must have been done implicitly. Okay, so with implicit differentiation, you can kind of get yourself in a little bit of trouble because you get too many variables, right? And if you don't have anything to plug in, it can get complicated. But here they're pretty easy derivatives. So what they're going to want us to do is kind of go back in time. Where did this come from? Right? Where did this come from? So first step that you're going to do is what's called separation of variables. That means we're going to get our y values and we're going to put them on one side. We're going to get our x values. We're going to put them on the other side. That includes dy and dx. Okay, so dx is considered an x value. dy is considered a y value. So what I'm going to do is I'm going to multiply the dx over to the right side. So I'm going to write dy is equal to negative y over x dx. Ta-da, section 6.2 right there, right? Differential functions. So there's a differential function. Now, I'm going to divide both sides by y now. So I get 1 over y dy is equal to negative 1 over x dx. Now, this is called separation of variables right here. You need to show this in order for you to be able to get a maximum of 4 or 5 points. If you don't show this step, then they close the door, and even if you get the answer right, they're not going to give you anything. Okay, so this is kind of like the key to getting all 5 points or all 4 points. Okay, and we'll see it when we're going over the test. I'll show you guys how they score them, but they always say 0 of 5 points if no separation of variables. Okay, so in other words, if you don't do this step, then you can't earn anything, even if you do the rest of it right. Okay, so make sure you guys show the separation of variables. So this is usually the starting point. Okay, from here you're going to integrate both sides. I always tell my students, show it in 2 different steps. Some people like to show the integration and the separation at the same time, and that's normally okay. I don't think it's a problem, but since they specifically state show me separation of variables, I'd rather like make it obvious. Heck, if you want to, you can even say separation of variables and point at it, right? To be like, look, there it is. right? I'm doing what I need to in order to open up the opportunity to gain some points. All right, so I'm going to integrate both sides here. The integral of 1 over y dy is natural log of y plus c, but I'm going to wait to write that on the right side, minus natural log, I'm sorry, I forgot the absolute value, natural log of x, and then plus c. Okay, so I have the natural log of y, or absolute value of y, equal to negative natural log of x plus c. So what I'm going to do now is I have to try to get y by itself, right? Because we always have f of x equal to something or y equal to something so that we can take a derivative of it. So I'm going to go ahead and try to get this so that it only says y. So I'm going to use e as my base. This is e to the negative ln of x plus c. Well, on the left side, I'm just going to get y equals to. Okay? And on the right side, this is e to the negative ln of x times e to the c. Now remember, the reason why I put times is because if you add powers, that means you had the same bases multiplied together, right? So if you have like x squared times x cubed, you can write x to the 2 plus 3, right? So if you have things added as a power, then it's multiplied. If they're subtracted, they're divided, okay? So if I were to see something like this, like x to the a minus b, that's basically x to the a over x to the b. Subtraction is division. Addition is multiplication, okay? So again, that's an algebra 1 property way back when. Now, at this point, I would, if they gave me an initial condition, if they said, hey, there's a point that belongs on the original graph, they might say like the point 1, 1. The point 1, 1 belongs on the original graph. Well, then what I would do at this point is plug in my 1, 1 for x and y and solve for c. Because I got to figure out what that missing constant value is. But I'm not giving you one right now, so we're not going to worry about it, okay? So I have y equal to, now e to the c, a constant to a constant power is a constant. I don't know what it is, but it's still a constant. So I'm just going to write big C here, e to the negative ln of x. Now this usually is a good answer for your general solution. They're not going to get you in trouble. You're going to earn a total of 4 points here. Okay, so if you're doing this on your AP exam, usually this is how the point values work. This is 1 point right here. Okay, this right here is another point, and this is another point for actually integrating both sides. You get a point for the integration of both sides. You get a point for the general solution. Okay, and then on occasion, if they're going to give you an initial condition, like an initial point, like the point 1, 2, or 3, 5, something like that, and you plug it in and you solve for C, and then you can put the value of C there to get the particular solution. Remember, this is called the general solution, okay? This is the general solution. It's called a general solution because it's just a general answer. I don't know what C is. C can be -2, it can be 5, 15, a 1/2. I don't know. So it's a general, it's a family of solutions, a family of functions, okay? But if they want a particular solution, and you'll know they want a particular solution because they will literally say, find the particular solution for this differential equation with an initial condition of, and they'll give you a point. So then you get to figure out the C value, okay? But for me, I just ask you general solution. So notice, here's 4 points. If you can do this on the AP exam, what I just did right here, you just passed the question, and you didn't even do, let's say this was part A. You haven't even touched part B or part C yet, okay? So you passed the question, the rest is icing on the cake, Okay, if you can get 3 more points, then guess what? Let's say you sucked at number 1 and you only got 1 point total, right? And here you got 7 points because you did this and you got like 3 more points overall. Well, those other 3 points can be shared with any other problem that you've done. So if this was number 2, let's say, and you were on number 1 and you only got 1 out of the 9 points and you feel terrible, and here you got 7, you won't know it, but I'm just saying, let's say you got 7 here and you feel pretty good about these 4. Heck, maybe you even got a 5th because you plugged in the value that they gave you. Well, you can keep 4 for this problem because that makes it still a passing score. And then the other 3 points, you can throw them over to your 1. That's what they'll do. And now your 1 point becomes 4. Now you pass question number 1, right? So your points, it's not just by question, it's as a whole. So you don't have to pass every question or a certain number of questions in order to pass the test. You just have to get a certain number of points. So you can share. Okay, they will do that. They'll average everything out. So don't feel bad if you have you're like looking at question 1 on the AP test and you're like, I have no idea what I'm doing. Get as many points as possible. Okay, if you can get 27, that'd be great. That means getting 3 questions completely right, which is totally possible. Okay, really, really possible. And maybe you might say, I can't get 3 whole questions right. That's gonna be really hard. Well, no, maybe you can't. But if you can get the sum of 27 points, you're fine because that's 50%. That's a 4 on the FRQ. Okay, so like I always tell people, it's easy to pass this test. How hard are you going to study? This test is simple. It really is. We're going to study it so many ways, so many times. You're going to feel comfortable with the types of questions. The thing is, how much are you going to practice, right? That's the key. Well, anyway, right here, we have what I want. I want to find the general solution. So that's my answer right there. Okay? And that gives you 4 points for sure. 5 points if they ask for a particular one. We would just have to plug in some numbers. Okay? So let me do one more of these and then we'll move on. The reason why I'm only going to do one more is because I already did number 2, like I said for you guys yesterday. So I already have that as an example. We're doing, remember that's the one where I forgot to put the over 2. I forgot who corrected me. Somebody over here? Who corrected me? Okay. But yeah, the over 2 part. So that's what I'm talking about. The general solution. Oh, and by the way, if I may, so here's that general solution I'm talking about. That was for number 2 right here. Okay. So it's on the notes. Okay. So just want to show you. It's on the notes. So let's do, I don't know, did I do the one down here? If I did, then that's great. Oh, I also did number 18. That's number 18. So I'm accidentally doing extra stuff I'm not supposed to do. But number 18, it's right there on your notes as well. By the way, if you're looking at this and saying, well, why isn't that one solved for y? You don't have to solve it for y. It's preferred. Okay? So you could have even wrote y squared equals to negative x squared plus c. You could do that. But I would not recommend y equals plus or minus the square root of this, because then they're going to say, well, which one are you doing, the positive or the negative? Now you got to get specific. Okay, so I tell you just to leave it like that. So let's see, let's try doing one more. I don't know, let's do number 1. I don't think I'm going to make you do number 3, so cross out number 3 from the problems I want you to do. Or you know what, we'll do number 5. So number 5 is, I think the rest will be okay. I'll double check them before I just kind of let you guys do it. So we've done number 2 yesterday. We did number 6 right now. I did 18 yesterday, and we're doing number 5 right now. All right, so separation of variables. Let's go ahead and do this. Is going to be dy dx. I'm sorry. What am I doing? I'm going to rewrite it. dy equals to y minus 1 dx. Notice I put in a parenthesis because it belongs together. Okay. Now, I need to get my y's on one side, my x's on the other. So I'm going to divide both sides by y minus 1. So it's going to look like this. Okay. And at that point, this is my separation of variables. Again, this is the key to allowed me to get more points, right? Here's a point, but now I can earn up to 4, up to 5, depending on the problem. So I'm going to integrate next. The integral of 1 over y minus 1 dy is equal to the integral of dx. What's the integral of 1 over y minus 1? ln of the absolute value of y minus 1. Good. Plus c, but I'm going to wait. And then the integral of 1 dx, that's just x, plus c. Okay? So at this point, I need to get y by itself. So I'm going to use e as a base. So e to the natural log absolute value of y minus 1 is equal to e to the x plus c. Okay? So once I do that, I get y minus 1 is equal to e to the x times, well, I'll put e to the c. And let me just clean this up a little bit. Y is equal to c e to the x plus 1. Because, again, it's e to the x times e to the c. E to the c is a constant. So it's a constant times e to the x. And then I'm moving the negative 1 over to the right side. So that's going to give me a plus 1. Now, this, again, is called my general solution. Let me just give you a little quick look at a particular. So again, this is called the general, okay? So general solution for us here. Let me fix the top part of this. If I told you, let me extend this. Find the particular solution. Again, particular meaning specific. Okay, this one is general. Okay, if I ask you for a particular solution, then that means I have to give you a specific point. So given the initial condition or initial point, usually they say the word condition though, of, hold on, I'm trying to think in my head, let's see, zero, 3. Okay, so in other words, 0, 3 is supposed to belong to the actual particular solution. I have the general one, but I know that the actual graph passes through 0, 3. So what they're now asking me for is find the actual graph. Don't give me any general stuff. Find the actual graph. So this is what you're going to do. Since they gave me x and y, what I'm going to do is plug it in. 3 equals c e to the 0 plus 1. This isn't hard, by the way. Okay, it's not hard to do the particular solution. The hard part is getting the general one, and then the other stuff's just solving. So e to the 0 is 1 plus 1. So 3 is equal to c plus 1. So c must be 2. Solving for c is usually a point, and if they don't give you a point there, the particular solution would be the next point. So my final answer then would be y equals 2 e to the x plus 1. This is the particular solution. So it just depends on what they want to ask you. Okay, so I'm going to look over the homework problems right now. I'll tell you which ones not to do, if any.